So here we're asked to consider the vector, which is negative 2 times square root 3i plus 2j. So we can see it has an x and a y component. So what we need to do is compute the magnitude and also the direction of the vector. And for the direction, we're measuring from the counterclockwise positive x-axis. Alright, so let's start by making a sketch of what this vector actually looks like. So it has a negative x component, which means it's going to point back to the left. And it has a positive y component, so it's going to point upwards. So the length of this vector here is 2 square root 3, and the length of this one here is 2. So what we're looking for in terms of the magnitude is going to be the length of this line in here. So I'll label it as E with the bars around it, meaning magnitude. And since we know that the x and the y components are always going to be 90 degrees to each other, we should be able to apply Pythagoras Theorem in order to figure out this magnitude. So it's the square root of the two components squared. So solving this, we've got 2 squared is 4, and then remember that the square is going to have to apply to both components in here. So for example, if I had a, b all squared, this could be rewritten as b squared times a squared. Okay, so here we're going to get 2 squared times the square root of 3 all squared. So 2 squared is going to be 4 again, and the square root and the square kind of cancel each other out, so this simplifies to just be 3. So it's going to be 4 plus 12, which is 16, and the square root of 16 is pretty easy. That's just going to be a 4. So that's the answer to the first part of the question. So the other bit that we need is the direction of E, and it's measured counterclockwise from the positive x-axis. So the positive x-axis would be out in this kind of direction, and counterclockwise is going to be this kind of direction. So we need to measure this angle, which I'll call theta, but it's going to be a little bit hard to get that straight away. So what we can do as kind of a pre-step is solve for this angle in here, which I'll call alpha. And then once we've got it, we know that a straight line has 180 degrees, so the difference between 180 and alpha should give us our answer. Alright, so what I might do is use tan, because tan of alpha is going to be the opposite over the adjacent. Okay, you could use sine or cos as well, since we've already solved for E, the magnitude, but it doesn't really matter. So, tan of alpha, it's opposite over adjacent, so 2 divided by 2 square root 3. And what we're going to find is the 2 on the top line is going to cancel with the 2 on the bottom line, so this just becomes 1 on square root 3. And what we want to find is alpha, so we're going to need to probably use our standard triangles if we don't have a calculator in order to figure out what angle would fulfill this relationship. So we have our 2 standard triangles that we can use. So one of them kind of looks like this, where we have 1, 2 and square root 3. And what we know is this is going to be 60 degrees, this is 30 degrees, and this is the right angle. Now I'll draw in the other one, but it's not going to be useful for this case. The other triangle, we have a 45 degree angle, and the side lengths are 1, 1, square root 2. So what we can see is that if we've got a 1 and a square root 3, that's probably suggesting we need to use this standard triangle, since square root 3 doesn't really appear on this one. So we want to figure out the tan of what angle would give us 1 on square root 3. So tan, remember, is equal to the opposite over the adjacent. So we want the opposite to be 1 and the adjacent to be square root 3. So if I pick 30 degrees as my angle, I think that's going to happen. Okay, so tan of 30 from this triangle, the opposite would be the 1, and the adjacent to that angle would be the square root 3. Alright, so from that, we can conclude that alpha would be equal to 30 degrees. Okay, so now that we have alpha is equal to 30, we should be able to figure out the angle measured counterclockwise from the positive x-axis, which is our theta. So theta is equal to 180 minus our alpha, which is 30. So we're going to end up with an answer of 150 degrees. So that's pretty much all there is for this question.